Welcome to this GCSE Science tutorial video on the evolution of the Earth's atmosphere. For the best GCSE Science content, please subscribe and click the bell icon. You can also find us on TikTok and Instagram. For the last 200 million years, the proportions of gases in the Earth's atmosphere have been much the same as they are today. Nitrogen is the most abundant gas in the atmosphere at around 78%. This is followed by oxygen at 21%, and the final 1% is made up of carbon dioxide at a concentration of 0.04%, and other gases like water vapour and argon, making up the rest of the remaining 1%. Theories of how the Earth's atmosphere was formed have changed and developed over time, much like the atmosphere itself. Evidence of the Earth's early atmosphere is limited. This is because the Earth is so old, 4.6 billion years old. However, the first billion years of the Earth's existence, that's from 4.6 to 3.6 billion years ago, there were high levels of volcanic activity, which caused the release of gases, mainly carbon dioxide, but also nitrogen, and methane, and some ammonia, and also water vapour. It is therefore thought that the early atmosphere of the Earth may have been like the atmosphere of Mars and Venus today, mainly carbon dioxide and very little oxygen. Over time, the water vapour that built up due to the volcanic activity condensed to form liquid water, and therefore the oceans. And over time, carbon dioxide levels in the atmosphere began to decrease. Carbon dioxide levels in the atmosphere decreased because a large amount of carbon dioxide was removed from the atmosphere as it dissolved in the newly formed oceans. This resulted in numerous chemical reactions taking place, and carbonate precipitates formed in the ocean as sediment as a result. Then, algae and green plants evolved and removed some carbon dioxide through photosynthesis. And the fourth reason, marine animals such as lobsters and crabs evolved, and the carbonates formed their shells and skeletons. The most common of these carbonates is calcium carbonate, as it is abundant in lobster and crab shells. And our fifth and final reason why carbon dioxide levels decreased in the Earth's early atmosphere is that carbon taken in by all of these organisms from the atmosphere and the ocean also became trapped in fossil fuels and rocks after they died. Let's have a look now at how fossil fuels are formed, starting with coal. Coal is formed from the remains of dead plants over millions of years. Dead plants build up under sediment, which ends up forming sedimentary rock, which is mainly limestone, which is mainly calcium carbonate. And these dead plants build up after being buried in swamps or in the sea. And then over many more millions of years, high temperatures and pressures over millions and millions of years eventually turn into coal. The coal is then mined and burnt as fuel. Crude oil and natural gas are formed from dead sea animals and plants. These sea animals and plants were buried on the seabed under sand and silt and rocks. And just like with coal, high temperatures and pressures over millions of years turned into crude oil and natural gas. And today, oil companies can drill down through the layers of rocks to remove the oil and gas. Gas is used mainly as a fuel, whereas crude oil can be separated out into fuels and also useful products such as plastics. As I briefly mentioned earlier in the video, initially the amount of oxygen in the Earth's atmosphere was very low. However, this began to change around 2.7 billion years ago when algae evolved. Now, algae carry out photosynthesis. And this means that the algae therefore absorb carbon dioxide and produce oxygen. Then over the next billion years, plants evolved, specifically green plants. This meant oxygen levels increased further because of an increase in photosynthesis. This increase in oxygen levels meant more advanced life forms, such as animals, could evolve. And now, for the last 200 million years or so, the composition of the atmosphere was much like it is today. That is 78% nitrogen, 21% oxygen, and 1% all the other gases such as argon, carbon dioxide, and water vapour. There is a lot of information in this video, so let's go through the main points in a quick summary. The first billion years of the Earth's existence, 4.6 billion years ago to 3.6 billion years ago, there were high levels of volcanic activity. This caused the release of gases, mainly carbon dioxide, but also nitrogen, methane, ammonia, and water vapour. There was very little oxygen in the atmosphere at this stage. Over time, the water vapour built up from volcanic activity and condensed to form liquid water and therefore the oceans. Carbon dioxide levels began to decrease because 1. A large amount of carbon dioxide was removed from the atmosphere as it dissolved in the newly formed oceans. 2. Carbonate precipitates formed in the ocean as sediment. 3. Algae and green plants evolved and removed some carbon dioxide through photosynthesis. 4. Marine animals such as lobsters and crabs evolved and the carbonates formed their shells and skeletons. 5. Carbon taken in by all of these organisms from the atmosphere and the ocean also became trapped in fossil fuels and rocks after they died. Algae and green plants photosynthesizing led to an increase in oxygen levels. And from around 200 million years ago to the present day, the composition of the Earth's atmosphere has been much the same. That is 78% nitrogen, 21% oxygen, and 1% the other gases such as carbon dioxide, water vapour, and argon. And that is the end of the video. Thank you once again for choosing Genius Science. And remember to work hard, be kind, and we'll see you in the next video.